evening, everybody, and welcome to the Night Show with Kathy Joe. Today's a very special night. It's been 4 long years, but he's finally back. Please help me welcome the Number Devil.
Hello, Kathy Joe. It's great to be back.
Thank you for coming. But why now? Why this year?
Well, I needed time to think about life and collect my knowledge until it was time for a new generation to learn my ways. Plus, you kind of took 4 years to contact me.
See, what's been taking all this time now?
Well, I had to recap on one of my favorite subjects, Pascal's triangle, and how the numbers were found. You see, one of my favorite parts is trying to determine the sum of the terms of the row, which is just simply 2 to the power of the row's number. Also, another thing that interests me the most of Pascal's triangle is figuring out the sequence and how to figure out the term of the rows, which is just simply finding the sum of the 2 terms of the row above it. To me, this makes it very easy to understand Pascal's triangle.
Wow. Is there anything else interesting about Pascal's triangle?
Well, there are many reasons, such as it helps me think due to its complex pattern, and after taking a long look at Pascal's triangle, there are many patterns to figure out the row number and also determine the terms of each row. Oh, and another one of my favorite subjects are permutations and combinations, which both determine the possible outcomes. However, for permutations, order does matter, but for combinations, order does not matter.
I see. Now, I've heard rumors about a secret 13th night. Did you really have one more lesson with Thomas? The world needs to know.
Yes, it's true. I hope to keep it a secret, but yes, there was a 13th night.
Now, if you don't mind me asking, what happened to that night?
Oh yeah, no problem. You see, it was the night after I just finished my last lesson with Thomas. So I went back to my office to relax the only way I know how, by obviously doing math problems. But then, something strange happened. Thomas called me back, asking for help. I thought I was done. Apparently not. So, confused, I quickly went back to his house, woke him up, and asked him what was wrong. He then later recalled how earlier in the day, his teacher, Mr. Bockel, had told him about this complex equation involving 2 polynomials and finding its quotient.
Wow, that's so interesting. But what is it exactly?
I'll show you. I just love it when someone asks for help.
Here we have an equation in which 8x cubed minus 10x squared minus x plus 3 is being divided by x minus 1. Now just like dividing numbers, see how many times the divisor x minus 1 can be multiplied so that the first variable x is equal to 8x cubed. This answer is 8x squared, so x minus 1 multiplied by 8x squared gets you 8x cubed minus 8x squared. Now subtract the dividend from the product, in which case the difference is negative 2x squared. Just like in dividing, don't forget to bring down the next variable, in this case is negative x. Now multiply the divisor x minus 1 again, so that the first variable x is now equal to negative 2x squared. This case is now negative 2x. Now, after finding the product, subtract that from negative 2x squared minus x. The difference is negative 3x. Then, don't forget to bring down the variable of 3. Now, multiply the divisor again so that x is now equal to negative 3x. This is now negative 3. Find the difference of negative 3x plus 3 minus negative 3x plus 3, which is 0. Since the quotient is 0, it can be concluded that the quotient of this equation is 8x squared minus 2x minus 3.
Wow, that seems so interesting and easy. But what happens if there's a remainder in the quotient? Does something special happen then?
Why, of course there is. Why don't we take a look?
So, say you're dividing polynomials trying to find the quotient as shown here. You factor everything out until you realize that your remainder is negative 13. You don't simply put down negative 13 as your remainder and be done. When factoring polynomials to find the remainder, it's always the remainder you have left all over the divisor, which in this case is negative 13 over 3x plus 1. To find the true quotient of this equation, add the quotient you found plus the remainder, which in this case The true quotient is 5x plus 1 minus 13 over 3x plus 1. Now, nothing really changes for the remainder rule if your remainder is a polynomial. The remainder you've still found, it still goes over the divisor and added to the quotient to find the true quotient of the equation, which in this case is 2x plus 1 minus 2x plus 4 all over 2x squared minus 4.
Ah, very interesting. But if you don't mind me asking, how did that night end up?
Oh, yes. Well, you see, I had to take him around this magical trip around the world of math until he could confidently answer and find the quotients of the polynomials, the usual stuff. Now, I'm still waiting to hear back from him to see if Mr. Balk will finally shut his primitive mouth about being the best math teacher ever. Sorry about that.
You're fine. But I think that's all the time we have today for this interview. Thank you so much, Dumbledore, for coming. It was so appreciated.
Oh, please, call me Tupletaxel. It's my pleasure. Well, see you again in 4 years.